Predictive models are basically tools that help us make educated guesses about the future based on data we already have. The idea is to look for patterns or relationships in historical data and use those insights to predict what might happen next. There are different kinds of predictive models. Some, like classification models, help us sort things into categories, like spam versus not spam, while regression models predict continuous values, like house prices, and clustering models group similar items together. One of the most straightforward and commonly used predictive models is linear regression. It's great for when you want to predict a number, say, someone's salary based on their years of experience. Linear regression works by assuming that there's a straight-line relationship between the thing you're trying to predict, the dependent variable, and the factors that influence it, the independent variables. The basic equation for simple linear regression looks like this. Y equals V0 plus V1 x plus E. Here, y is your prediction, x is your input. V0 is where the line crosses the y-axis, the intercept. V1 is how steep the line is, the slope, and E is just the error or noise that the model can't explain. If you have more than one input, you move to multiple linear regression, which just adds more terms for each input. Y, eat, 0, s, eat box, x1, is 2x2 plus v1xn plus n. To really get the hang of linear regression, there are a few key things to keep in mind. First, the assumptions. The relationship should be linear. The errors should be independent and spread out evenly, homoscedasticity, and the errors should ideally follow a normal distribution. Next, there's model fitting, which usually involves finding the line that minimizes the sum of squared differences between the actual and predicted values, a method called least squares. When you interpret the model, each coefficient tells you how much the outcome is expected to change if you tweak one input, keeping everything else the same. Finally, to see how well your model is doing, you can look at metrics like R-squared, which shows how much of the variation in your outcome is explained by your inputs, mean squared error, and by checking the residuals, the differences between actual and predicted values. Understanding these basics will give you a solid foundation for building, interpreting, and evaluating linear regression models, making them a valuable addition to your predictive modeling toolkit.